What we're going to take a look at today is factoring GCF, which is the greatest common factor, and then also factoring by grouping. All right, the GCF is going to present itself all over the place. Anytime we are asked to factor, this should be the first thing that we look for. And as the name describes, the greatest common factor. So we need to find the greatest common factor as we go through here. We have one example on these, but if you need help, we will take some time and look at those things. So this is our first example that you should see on Delta Math. And what I'm going to notice first of all is that these both have x's. So if they both have x's, I definitely can at least factor out an x. What you got to remember about factoring out a GCF is you cannot factor more than the lowest one has. And if they don't all have x's, then you cannot factor that one out as well. So we're going to actually take care of the variables first, and then we will talk about the numbers. So I can factor out 4 x's. They can both sacrifice 4 x's. Now when I pull the 4 x's away from these two numbers, the 5 x's will now be down to 1x, and the x to the fourth power will now have no more x's. So this still accounts for all of our x's. It's kind of the opposite of distribution factoring is. It's really mathematically dividing them out. So when we factor these out, we've divided them out, and this is what we have. Now the numbers, some people may be a little better at finding common factors than others. If you are struggling, one thing you can do on these is the good old factoring tree. I'm actually going to move the 27 to the other side just so I have a little more room. So I'm going to use my factoring tree and break these down, and anything that they share I can factor out. So 27 is 3 times 9, and 3 is 3 times 3, or 9 is 3 times 3, excuse me. And then I go over to the 24. You can pick any number of these that you want. So I factor out a 6 times 4. You could have used 12 and 2. That's completely up to you. 6 factors down to 2 times 3. 4 factors down to 2 times 2. So when I'm looking for this GCF, using the factoring tree actually works in two ways. One, I can find a common factor. In this case, they actually don't share very much. All I can see that they share is this 3, and any of these 3's from the 27. Doesn't matter which one. So the GCF numerically is the number 3. So I'm going to take whatever they share and put it out to the front here. That is our greatest common factor. And what's nice about the factoring tree is we now also have what's left. So we have a 3 and a 3, 3 times 3, which did not get factored from the 27. So 3 times 3, I'm going to put that back. 3 times 3 is 9. So we'll have a 9 right there. And on the other side, we have 2 times 2 times 2. Well, that's 2 to the third power. 2 times 2 times 2 is 8. So I'm going to replace the 8 back in there. So when I factor out a GCF, again, like I said, it's the opposite of distribution. This is how we do this. And if you're not certain, you can always distribute back in and make sure that it comes back to the original answer. Here's another thing you can do. We talked about this the other day. Good old y equals. y1 equals my first thing. y2 equals this. If my tables match identically, what that means is I have another version of the question. So this is called factoring the GCF. This should be step number 1. Anytime we're asked to factor, find a GCF, because if you do not pull out your GCF, you're going to run into some issues later on, and you're usually going to work with harder maths if you don't. So try to remember to take out your GCF. Now I've got one that doesn't have any numbers. This is just variables. Well, the variables usually work a little bit easier. So what I have here is x times y. That's what x squared times y is. If you don't have to rewrite it this way, I'm just showing you another visual look at these. And y squared is y times y. So they can share a y. So if they share a y, if they factor out They can factor out, excuse me. So I'm going to factor out my y. When I factor out my y, well, there's still x squared left from the first one, and there's only a single y left from the second. One thing that didn't happen here, but it was very close, make sure, put a little star for yourself on this. Little star. You never factor down to 0. You can never factor something away. So if you factor out everything, what you have left is the number 1. So let's just say this one was y squared. This is our answer, of course. This is one of the delta maths. Let's say this did have a y squared. Well, that means I could have pulled out a y squared, leaving me with x squared. Since I pulled out all of the y's, they're no longer there. And on the other side, I pulled out the y squared, given there was a y squared. So that does not factor down to a 0. What that does is it factors down to 1. So if that would have looked that way, that's what we would have had. And then the last thing we're going to talk about is factoring by grouping. Now, when we factor by grouping, this is what we're normally going to do. This should be a real big red flag here. We've got a red flag because we have 4 terms. Really, to be honest with you, more than 3 terms means this is going to probably be factoring by grouping. There are some exceptions to that, but rarely. So the grouping can be done all kinds of ways. You could have grouped this one and this one, whatever you want to do. But generally, it's a good idea to factor the ones that are closest in power. So that's what I'm going to do. I'm going to group these 2 terms. Now, I want you to watch how I write this. I do not put my parentheses around this because that is indicating that I have a positive 6. But I don't have a positive 6. I have a negative 6. So I need to group around that negative 6, and then I like to come in here and impose a plus sign. The reason why I do that is because if I don't, a lot of times my mind thinks, well, I've turned this into multiplication, which it is not. So here's where we're going to find the GCF. And by the way, we should have asked if there was a GCF to start this question. They all have x's except for the 42, so the x is not a GCF. This does not have a GCF. So now we'll move about our business. And again, we look at these things and we say, okay, well, they both have x's, and more specifically, they both have x squared. When I pull an x squared from an x cubed, I have a single x. When I pull an x squared from a negative 7x squared, I have negative 7. All right. Told you, good teacher, bad teacher stuff. Okay, I'm going to jump to bad teacher just for a minute. I'm just telling you right now, when it's factoring by grouping, it is not a rule that the other one has to have an x minus 7 when factored out. But I'm telling you, most of the time it will. Because if you don't have these match out, what that means is it's not factorable. So if we have this knowledge, what we can do is kind of figure out what the greatest common factor was just based on where this is going. Here's what I'm talking about. I need the other side to be an x. Well, there's a negative 6 here. So if I'm going to factor down to get an x like the first one has, I have to factor out a negative 6. Now, obviously, 6 goes into 6. And then the next question is, well, does 6 go into 42? And it does. And then here's a real big shocker if you didn't see this one coming. X, and then remember, I factored out a negative from a positive 42, which means this will be negative 7. And here's the big shocker of the day. These do match. I like to even operate under this assumption because if this doesn't work, all I'm going to do is circle the answer because it's not factorable. Now, you cannot just presume that it's going to match, but I'm telling you right now, It's a really good place to look, but you need to get confirmation that they do actually match. All right, here's where people generally have an issue. I'm going to go over to the side here and just take a little detour, and hopefully this will make some sense in just a moment. So when I have 2x plus 3x, think about that real quick. I can combine these and call this 5x because they are like terms. What makes something a like term is they are being multiplied by the same amount. If this would have been 2x and 3y, I couldn't have done anything because they are not being multiplied by the same amount. So what I can do on these is combine the numbers in front of the multiplication. In this case, that was 2 and 3, which makes 5, and multiply one time. You guys have ever seen anybody at a cash register when you have multiple items? They don't necessarily ring up. You know, if you've gone to Lowe's, they don't ring up 20 boards. If you have 20 boards, they ring up one and then they type in 20. That's essentially the same thing. So when you have the same item, in this case, we're talking about a variable, you can add them up and multiply one time. Well, that's what we have happening over here. We have two values that are being multiplied by the same amount. It does not matter that this amount is a binomial. All that matters is that they are being multiplied by the same amount. So what I can do is I can add the two values together. Let's use the word combine because this is actually a subtraction sign. I can combine the two numbers, x squared minus 6, and now they are being combined, so I need to put them in parentheses, and multiply once. Since both the negative 6, and the x squared are both being multiplied times x minus 7, what I do is I put those two numbers together and multiply once. So this is what our factoring by grouping is. By the way, if you're a little uncertain, you don't have to go through and redo everything. Type y1 equals into your calculator and put the original question. Type in y2 into your calculator. And if their tables match, which these will, if the tables match, then you have a simplified version of the answer. So this is our factoring by grouping. It's very important that we get good at this because tomorrow we're going to build off of this one using what I call the AC method. Some people call it the master product. It's probably the most difficult part of factoring. So make sure as you work through these that you get this idea. A lot of times people have a little bit of a struggle with this. If you do, speak up. Remember, we've got to get this factoring down.